Forgot to record now. Okay, so now we say that is about the electrons emitted from the ground state to the excited state, and they retain in excited state for a few seconds, and then come back to the ground state. When they come back, that atom, okay, we say they come back from this excited state to the ground state. So that at the time they generate the light. Okay, means emission of a light takes place, and that emit the light that we can say that it has a photon of a light, you can say, and it has some particular frequency. It is depending upon that HV, and that emission of a light of, or we can say that is about that is depending upon that how how much is the energy in that state. So ground state we say E1, excited state we say E2. So HV is equal to what? E2 minus E1. That E2 is nothing but what? Energy in the higher state, and E1 is the energy in the lower state there. And this particular process is called as a spontaneous emission. So this process we can say, if you see that this, when we apply any when we give them any external source, applying an external source to the device, then that energy of that atom that changes from this state of that changes from the ground state to the higher excited state there. Okay, then in that case that they emit the electron. So this is about the factor we say here. Okay, if you see that each electron is triggered into the emission. Okay, this one is mentioned by the presence of electromagnetic radiation of the proper frequency, and that is called as a stimulated emission. Next, the absorption. In the absorptions, what happen here? So that we say that is the atom. We say when we it initially whatever we can say that is about the atom is initially in the level one, and we interact with the electromagnetic energy. This is about your electromagnetic energy, and it has a frequency of what we can say V at it. You had mentioned the VR now. We can say that is about the V. Now then, what happened? The atom may now undergo a transition to the level two from E1 to E2. And in that case, what happened? Absorbing the energy from that incident radiation. Okay, this is about the incident radiation, and that we can say that that atom, okay, absorbing the required energy from the incident radiation, and that phenomena is called as the absorption. There are the two phenomena: one is stimulated emission, absorption, and another is about a, we can say that is about a, okay, spontaneous emission. Okay, so there is about a spontaneous emission, stimulated emission, and a, we say we have the absorption. Okay, now spontaneous emission means what? We apply the energy, then that is about spontaneous emission, and a stimulated emission means we can say that uh, in a spontaneous emission, what happen? So that electrons will be no longer in that particular period. Okay, so we can say it will not be available for this particular period. But in the case of a stimulated emission, what happen? That excited energy, we say that is about the E2 and E1, then electron will change their energy from the excited state to the ground state. Okay, so that is about, we can say, emission. That is about a stimulated emission. Okay, so it stimulate the incident light by emitting the photon. We say that is called as stimulation there. Okay, so now then how this action takes place? You can see there. This one is about the absorption. It's about the light energy, or you can say electromagnetic energy. It will absorb here. Next, about a stimulated emission. It's a spontaneous emission. It changes that excitation there. Okay, so it generates that a emission of electron. Then it is again a further we say stimulated emission. It excited. Okay, now it will back here. So we'll get that. Okay, this one. Okay, so that's about the that light we are getting. It emits, and that is about it emits the photon of the same frequency. Okay, so that's why you can say that the action is called as a stimulated emission there. Okay, so here in this case, stimulate the incident light by emitting the photon of exactly the same frequency. That's why it is called as a stimulated emission. Now in the stimulated emission, and what happened there? Incident light photon. Okay, because of that we say that is about generated the same frequency of a light, but that emission, that light emission, that is nothing but a coherent stimulated light. Okay, coherent stimulated light. Now, if that particular material, okay, has a good number of excited atoms, then what happens? That process gets multiplied, and because of that process get multiplied, so we'll get that a intense coherent light beam that will be emitted from that particular substance or a atom there. So that is about that. So for that purpose, we can use a pumping process. Okay, so we can prove the process of a pumping there, so that more number of electrons can be excited from the device there. So that is called as a that pumping. We can say it is about a generally we say it is about a population inversion takes place in that particular case, and this one happen in the laser diode. So in this case, what happen? Generally, we say that generally electrons tend to a ground state, and if a substantial percentage of atoms could somehow be excited into a upper state, leaving the lower state all the empty. Okay, so that is called as a population inversion. An incident of photon proper frequency could then trigger an avalanche of stimulated photon all in phase. Okay, that is about you can say a laser there. So now this is about the process of a laser. So we can say that is about the excitation of how that electron will be excited in the state there. Okay. So these are about the case here. We say ground state E1, E2 excited state there. Okay. Likewise, we have excited state, and we get the output as a amplification. Now this particular process, okay, so it generates a what we can say that is about a beam there. So or we can say that we will use a external okay pumping source. Okay, or pumping source means what? Will supply the energy. Okay, we will supply the different energy to the material. Okay, this one is about a pump. We say, or we can say that about the pumping source. When we supply the energy to the atom at a particular frequency, and then what happened? Then because of that pumping, they raise their energy. Okay, they raise their energy to the higher level than the ground level, or we can say that they raise their energy to the from we can say from the ground level to the another highest state there. Okay, that's why we can say it is about the metastable there. But what happened here when we provide okay that energy supplied uh, so that it will get that we'll get that higher energy level. Okay, that electron or we can say that uh, that atom raise their energy from the lower energy state to the higher energy state using the pumping source. Okay, so then when we pump, so that's why energy raises from the ground level to the highest level. Okay, but again, that pumping is to be done at a particular frequency. Okay, we need to done that pumping at a particular frequency so that there won't be any difference in the energy level. There won't be any difference in that energy level, or we can say that there won't be any difference in the frequency. We are expecting the desired frequency, so that's why we need to do the pumping at a frequency whichever we require, so that energy difference between that particular two signals or two different frequency signals will be different there. So that's why we use a pumping at a different at a same frequency there. Okay, so that's why when we use this at a same frequency, then amplification takes place. So we'll get the amplified output when we use the pumping with a same frequency. So we'll get that a beam that we can say it is about a collimated beam. So generally there are the types of pumping source. We say it is optical pumping. And that optical pumping it is suitable for liquid and a solid laser because they have the wide absorption band. Again we say another one is about the electrical pumping. It will be suitable for the GAS laser because they have the narrow absorption band. Again another pumping source is nothing but the chemical reaction. Now we say there are the various types of laser. And that various types of laser, if you consider that, it is depending upon that what material we have. So according to the material, according to the active material. There are types of laser based on that solid state, we say liquid, gas, or the materials we are using. So there will be a types of material, and that laser types again we can define in terms of a wavelength. So what type of wavelength we are using? That is about the infrared, visible, ultraviolet, or a X-ray laser. That is about the types of laser based on the material as well as the based on the wavelength. And then again the wavelength that lasers again it is depending upon that what type of a lasing material they have. So solid state lasers having a lasing material or a semiconductor laser sometimes called as a diode. Okay, these are about the various types of laser that is to be used and for the different applications. If you consider that a semiconductor laser that will be used in laser printers or a CD players. Okay, nowadays CD player is not present. Okay, that's the and nowadays okay, everyone have that pen drives and all. Okay, these people are using nowadays. No one is using that DVD writing and all the thing. So now different lasers. Okay, there are the different lasers with a different wavelengths, and that use for those particular laser is a different thing. Now this is about a rhodamic 6G in the liquid solution or a suspension as a lasing media. They are tunable over a broad range of a wavelength. Now these gas lasers are pumped by the current and they are using for the cutting the hard material. And then excimer lasers, okay, so they are laser is used in a ultraviolet there. Okay, that is about the different types of a lasers we have. Another one is about a ruby laser there or solid state laser. Okay, instead of using word L, so you can use a mesers also, microwave amplification. Okay, by stimulated. Okay, so we can say that's about mesers also. The use is same. Okay, so only here we can consider that uh, this particular uh, the ruby mesers or a ruby laser, they are manufacturing by the various gaseous material. Okay, so these are this one is about a different gaseous materials are used for the developing this lasers or a measure there. But if you consider that working, okay, how they use because the range of frequencies used or that is about the broad range of frequencies these devices are used, and these devices they have the population inversion there takes place there in this particular thing. Operation of a wavelength we say operation wavelength 694.3 nanometer. Okay, we say it is infrared band. It has a three-level system, absorbs green blue light. Okay, we say it has a gain medium, crystal of aluminum oxide with a small part of atoms. Aluminum is replaced with a chromium 3 ion. Okay, pump source is about a flash lamp. Okay, the ends of a ruby rod serve as a laser mirrors. So now this one is about we say a ruby laser there. So in that case, if you see that here, we provide okay excitation or a pump source there, and we'll get that laser beam likewise. Okay, this is about your crystal. This is about a laser crystal, and we say okay, so you can provide supply to this. It is act as a we can say it reflective mirror, and this is about a tube. We'll get through that. We'll get that. It's about a laser beam. So how it works? High voltage electricity causes the quartz flash tube to emit okay an intense burst of a light. So we'll get that a light, and that light is nothing but exciting some of the chromium. Okay, or we can say that the body will provide that high energy level of the crystal, or we can say that a light we are getting. Sorry. Now at a specific energy level, this emits a photon. Okay, so that when we can say that about the it emits a photon, so light intensity is rapidly amplified. So mirrors at each end reflect the photon back and forth, continuing this process of stimulated emission and amplification. The photon leaves through the partially sealed mirror at one end. This is the laser light. Now here, okay, it is when the about a mirror present. So electrons will back and forth takes place in this region, and then photons leave through the partially silvered mirror. Okay, this one at one end, and then this is nothing but a laser light. So high and low level lasers. High level lasers, they are used in a surgical for a surgical lasers, hard lasers, thermal lasers, energy level laser. Okay, have the energy of a 3000, 10,000 milliwatt there. Low level lasers, medical lasers, soft lasers, subthermal lasers, energy. They can say that about energy of 1 to 500. It is about therapeutical one. So now these types of laser nowadays, the laser treatment is for the burning the cancer tissues or healing the wounds and all. So in the, most of the medical uh, treatment that lasers are used. So generally laser parameters has the wavelength, it has some output we say, again average power and what will be the intensity. So wavelength, different types of material, according to that we'll get the different wavelength there. Okay, so that is the based, everything is based on the whatever the wavelength there. So then wavelength changes, so it affects the power, so that's why wavelength is affected by the power. So then output power, so as per the requirement, we use the device so that it will generate a high output power or low output power there. So it then the average power. Okay, likewise we have the different power there. So according to output power and here again that is again another word is about the intensity. So intensity depending upon that we say light. Okay, emits from the device. So that's why we say that's about the light, whether it is a laser diode or a LED we are using. So according to that, that it emits the light and we should know that is about the beam area for this particular light there. So generally we say it is a narrow beam and the light is about a coherent one. So that's why it is about a narrow beam we are getting, high intensity light we are getting. So for a treatment, lasers use and we say that is about word we are using a dosages. Okay, high dose, low dose, and that dosages are depending upon that how much is the output of a laser in milliwatt and the dosage, how much is the amount of energy applied to the given particular area. If supposed to be any cancer tissue is there, so we use for given area and how long that we can say that how long that output is to be there, or we can say that is the time of exposure. Okay, that time of exposure for that particular area, particular region. That is dosage depend upon that output and the time of exposure, and then beam surface area of a laser there. So that this way we can use as a laser in a treatment. Okay, so that is about to remove the tissues, okay, cancer tissues, or we can heal the wounds and all. So generally how it works, so some target we have, so here the laser beam is to focus on the given target, then we need to say now this one is nothing but a tissue we say. Okay, so this one is about a target, and for this particular target, when we expose to this particular light, then this tissue will burn. Okay, so that is about burning, but we could not burn for the longer duration or longer period there. Okay, there are the side effects for all the things. So that's why it is about it for a small period of a time. So we say here, that's why we say that the dosage, which a word we have used, a dosage word, output of a laser, time of exposure, and a surface area. How okay it will work. Okay, that is about a laser. The nowadays you know that that is for skin and all. So these lasers are used to remove the moles. Okay, for glowing the skins and all. These are about the lasers are used. So there have, again now it is saying it is word about no side effects. Okay, but any external thing when we apply it on your face, okay, natural thing. Naturally we say they have a side effect. Even if they are saying no side effects, we are there may be a side effect in the future. Okay, so that's why we say that about it. They can use for the different purpose, natural healing and pain relief, wound healing. There we can use. Okay, so you can say that so develops a collagen and muscle tissues there, increase the macrophage activity. Okay, alters sever conduction velocity. That's about the stimulate the nervous function or stimulate the immune system. So these are about the of use of this particular laser diode. So it improves the blood circulation and vasodilation. Means we can say that it increases the blood supply, increases the ADP production. Okay, so we can say that relieves acute and chronic pain we have, reduces inflammation. Okay, so that is about the tissues. tissue and what you can say, it is about a response we say. Magnitude of tissue reaction are based on the physical characteristics of what? Wavelength, we say frequency, density of a power, duration of a treatment, and vascularity of a target tissue. Okay, this is about a muscles generally we say for that particular place, okay, particular area. And then a direct effect occurs from what? Absorptions of a photon. Indirect effect produced by the chemical events caused by or interaction of photons emitted from or laser and the tissues there. So there are the types of lasers we say earlier, that is depending upon that wavelength and all. But they have some standard, and that standard they have defined class 1 lasers, class 2 lasers. Okay, likewise, they are the types of lasers. So right now we are not able to understand. We no need to understand what are the types and all. Okay, just remember that these are the various types of a laser. They are used for the specific applications and all. Okay, that is from my side. Okay.